Hello, welcome. Today let's try to solve another Leetcode problem. 1204 sum of subarray ranges. So for this problem, I'm gonna use the brute force way, which the time complexity is O(n) squared, and then I'm gonna optimize it to O(n) by using monotonic stack. So let's first check the problem. So we are given an array. We want to calculate the sum of subarray ranges. So how it is calculated? It is the maximum number inside the subarray minus the minimum number. So how many subarrays? In total there are 6 for 1, 2, and 3. So for each of them, we're gonna use the maximum minus the minimum, and then we're gonna sum of all those numbers. Yeah. So the straightforward way is by using the brute force. So this is what I written for the brute force method. So I just need to use n to be the length of the array, and then I prepare another variable result for my final result. Yeah, I just need to use the two for loops. So for the first for loop, outer loop, I need to prepare a minimum. So mn is the minimum and the maximum. Yeah, so it would be the first number, nums I, and then for the index j, we'll start from I to n. So for each of the j, I will have the minimum and maximum number. So this means from I to j, inside the window of I to j, I have a minimum number and a maximum number. So the result just need to plus the maximum minus the minimum. So this is what exactly said in the description and the example, as you can see it. So this is just O(n) time complexity. Now let me just run it to check if it works. I need to change this array to nums because sometimes I will use the template code. Yeah, so now it is what? Did I do something wrong? Let me check. Yeah, so I needed to change this array to nums because basically it is nums from the beginning. I changed it to array to use some other template. Yeah. Now, as you can see, it works. Now let me just submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's not so fast. It is just 30% of all Python submissions and it's likely 3 seconds. It's nearly 3 seconds. And the time complexity is just O(n) squared. As you can see, there are 2 for loops, and for each of the for loop, it is n. So the 2 for loop, it is O(n) squared. As you can see, the number of n is maximum to be 1000. Now we need to do the follow-up. Could you find a solution with O(n) time complexity? If we were to find O(n) time complexity, it must be a hard problem. Yeah, if it is O(n) log n, it cannot be so hard because basically inside the window we can use from the sorted containers in Python, we can use the sorted list. So inside the window, we know the minimum and maximum number. Yeah, it is just log n time. So the time complexity will be n log n. Yeah, but we want to solve it in O(n) time. So it must be the monotonic stack. To solve this problem in O(n) time, we need to know another problem first. So this problem, Leetcode 907, sum of subarray minimums. I've already posted the video for this problem. Yeah. So to understand the current problem, this one, sum of subarray ranges. So you need to understand this problem first, because basically, if you understand this problem, so for that one, you just need to copy and paste the code, and then, you just copy and paste and change a little bit, it should work. Now let me just copy and paste the code, and then let me explain why we can use the previous code to solve the current problem. Yeah, basically it is the subarray. Inside the subarray, we need to find the minimum and the maximum. Let me find an example to explain it. So for example, if we just want to find two numbers, if it is just 1 and 2, yeah, it must be a very simple example. So for this number 1 and 2, inside the array 1 and 2, we want to find the minimum and maximum. So how should we solve the problem? Yeah, basically we need to find 1, 2, 1 and 2. There are three combinations. For the first one, it is 1. So for this one, the maximum and minimum, 1 minus 1, it is 0. Similarly, for this 2, it is 0. And for this 1 and 2, the maximum is 2, minimum is 1, so it is 1. So the final result is 0 plus 0 plus 1. So the final result is 1. Yeah. But how can we solve it easily? By using some high advanced algorithm like monotonic stack. So for this problem, we are asked to inside a subarray, we want to find the minimum and maximum numbers. But from the previous Leetcode problem, we always want to find the sum of the minimum numbers. Yeah, if you can find a way to find all the minimum numbers, basically you're gonna use the monotonic stack. And similarly, if you want to find the maximum numbers inside all the subarrays, you can still use the monotonic stack. But why it is helpful to solve this problem? Now we can analyze it. So for the first number for this 1, so if this number 1 is the minimum number, how many combinations for this subarray, including this 1? So there's only 1. Because if 1 and 2, the minimum, it includes 2 subarrays. If the minimum is 1, it includes 1, and 1 and 2. So it includes 2 combinations. If the minimum is just 1. Yeah. So if the minimum 1, there are 2 combinations. So what about the minimum of 2? Yeah. So for the minimum 1, there are 2 combinations. So for the minimum of 2, there are only 1 combinations. Why? Because it is only 2. If it is 1 and 2, the minimum is 1, but currently the minimum is 2. Yeah. So those 1 and 2s, so this 1 and this 2 are all the combinations, all the possible cases. We just need to enumerate all the cases of the minimum if it is 1 or if it is 2. So what is the result? It is for the 1, for the minimum is 1, it includes 2 combinations. It is 1 and 1, 2. For this 2, it only includes 2. It is 1 combinations. So basically, if we just want to calculate the minimum, it is 1 times 2 plus 2 times 1. It is 4. Yeah. If we want to calculate the maximum, so for the maximum, if it is 1, how many combinations? It is just 1. Because if it is 1 and 2, the maximum should be 2. But currently it is 1, so it is 1 combinations. So if the maximum is 2, how many combinations? It is 2, because 1, 2, it is 1 combination, another is 2, so it is 2 combinations. So the final result would be 1 plus 1 plus 2 plus 2 times 2. 1 times 1 plus 2 times 2, it is 5. So what is the result? The final result would be the maximum combinations minus the minimum combinations. So what it is? It is 5 plus 4. So the final result is 1. So this is exactly like what we calculated before by the brute force. But here, this way, we just find the minimum possible ones. And then we find the minimum possible numbers if it is 1 and if it is 2. And then we're going to check if the maximum possible numbers if it is 1 and if it is 2. Yeah. And but how we find it? We exactly use the Leetcode problem 907. We're gonna find it inside a window. Yeah. By the monotonic stack, we can find the numbers inside a window if the minimum is 1 or if it is 2. Because if there are more numbers like 1, 2, 3, and 2. Yeah, so for this example, if we want to find this 2, if the 2 is the minimum, so for the left side, it can only go to here. Yeah, because it cannot go to 1 because the minimum is 2. And for the right side, it can go to 3 and 2. So there are two possible cases. One case, if we can include the 2, another case, we will not include the 2. So this is just a special case I analyzed in the Leetcode problem 907, and you can check the video. So for this one, so for if the minimum is 2, basically we can use a monotonic stack to find a window. So this window 2, 3, and 2, so the minimum is 2. And by this window, we can find how many combinations of this 2. Yeah, and similarly, we can use this way to check all the numbers like 1, 2, 3, and 2. Yeah, so that is the minimum combinations. Similarly, we can use this way to find the maximum combinations. We just need to use the maximum combinations minus the minimum combinations, and that would be the final result. Now let me just go back to the code editor to finish the coding. Yeah, as I explained, I'm gonna use the previous code from Leetcode 907. Basically, that is to calculate the minimum, sum of the minimum ranges, and this one is the sum of the subarray ranges. Basically, it's maximum minus the minimum. Yeah, and similarly, you can also use it to solve other problems, like some of the maximum subarrays inside of ranges. Yeah, because this is basically maximum minus the minimum. If you know this idea, basically you can use a monotonic stack to solve all those problems. Now let me use the previous code. Because we don't need to use the modular for this one, let me just delete the modular. And up to now, this code is to calculate is used to calculate the sum of the minimum subarray ranges. Yeah, minimum of the subarray. Basically, it's the sum of the minimum subarray. Yeah. Now I will prepare the result to be a minimum. It will be mn equals to sum of those results. Yeah. Now I just need to copy and paste everything, I believe, and just get the final result. Yeah, you might think the code is too much longer than expected, but I think it is okay. Basically, it is just like 10 lines of code, and then you just copy 4 times and get the final result. It seems you are using 4 times of monotonic stack. Yeah, it can be the increasing stack or decreasing stack, depend on while you are calculating the minimum or the maximum numbers. Yeah, basically from here it is the sum of the minimum. Now from here we're gonna change it to sum of the maximum, so it's gonna be the maximum, and we just need to return the maximum minus the minimum. Yeah, and for here we just need to change a little bit about the monotonic stack. Let's say, so here I prepared everything, and here I have the stack, and the left and the right. Yeah, it's also the same like before, but here I should use a less, because if I were to calculate the maximum number, basically I just need to change the sign. Yeah, change the less than sign, change the more than sign to the less than sign. Basically, it's gonna work. Yeah, this is used to calculate the maximum from the left side, and here is used to calculate the maximum from the right side. So more than should be changed to less than. Yeah, so here just need to change it to less than. Yeah, because here you cannot use two equal sign, because otherwise there will be more duplicate. This equal sign is just used to avoid duplicate, because if here equal, it means include some duplicate numbers, and here not equal will not include. Now let me explain this example here. Yeah, so like 2, 3, and 2, basically if you are calculating this 2 number here, it is 2, 3, 2 for the minimum 2. Yeah, while you are go to this number 2, if you use this 2 as the minimum number, if you want to include this 2, as you can see, it will have duplicate. So this is Why? If you are using left without the equal sign, so for the right side, you have to use the equal sign. Yeah. So for this way, you can avoid the duplicate. Now let me check if everything is okay. So yeah, this is the maximum sum of all the possible cases and minus the minimum sum of all the possible cases. Yeah. Let me just submit it to check if it works. The array is not defined because for that problem, basically it is an array. So here I just needed to change this number to array. Yeah, because if you change the array, it would be so many places. Yeah. Now let me just run it. As you can see, it passed. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and it's pretty fast. Before, if you remember, it is 3 seconds. Now it becomes 80 milliseconds and it is 65% of all Python submissions. Now let's analyze just a little bit about the time complexity. Because this is n, it's only 1000 from here. And basically here we use the 4 monotonic stack. But for each of the monotonic stack, the time complexity is just On. So the final time complexity is On, and the space complexity is also On because we use the stack, left, and right array. Thank you for watching. If you think this is helpful, please like and subscribe. I will prepare more Leetcode problems like this. See you next time.